So we're going to do negation of statement. It will be negation of simple statement, and then it will be then the negation of compound statement, right? So right now, negation of simple statement we are seeing. Sun is a star. So we can have the truth value for the statement as true, because sun is a star is a true statement. So we can say truth value is capital T. Then we have negation P. Negation P is to change the truth value to false. Now true will change to false, right? And negation P is a statement where I can say sun is not a star. So we write the negation as not a star. We put not inside. So negation P. Sun is not a star is the statement, and it is a false statement because sun is star is true. Sun is not a star is false. Okay. So that is the simple explanation for negation. Now for compound statements, if you want to take negation of a conjunction, so negation of P and Q, it is as good as writing A intersection B the whole dash. Negation means you are taking the complement. So it is A intersection B the whole dash from set theory, which will be equal to A dash union B dash, De Morgan's law. So if you have A union B the whole dash, it will be taken as A dash intersection B dash, right? Same. If you want negation of conjunction, it is logically equivalent to negation P or negation Q. This can be proved using truth table. Okay, so I am leaving it up to you. De Morgan's law can be proved using truth table. Okay. De Morgan's law, we have one more law, which is negation of disjunction. The negation of disjunction is negation P and or becomes and it is negation Q. So we have union, intersection. Their intersection is union. Okay. Then we have negation of P implies Q. To find out negation of conditional statement P implies Q, what we are supposed to do is we will take negation of negation P or Q. So we have negation of negation P or Q. This we have proved in the previous video, that P implies Q is logically equivalent to negation of P or Q. And then we are going to take negation inside. So what we get is negation of negation P and negation Q, De Morgan's law. And in that now, negation of negation P is P, right? Negative becomes positive. It is as simple as that. So if P is true, negation P will be false, and negation of negation P is again true. Okay? Comes back to original. Negation of P double implies Q can be taken as negation of P implies Q and Q implies P. P implies Q and Q implies P, and it will be negation of P implies Q or negation of Q implies P, right? And finally, we can write this is De Morgan's law, and then we can use negation of P implies Q, whereas P and negation Q rule, and we can write this as P and negation Q, or we can write this as Q and negation P. Okay, that is negation of double implication, P and negation Q or Q and negation P. This is negation of implication, it is P and negation Q. Negation of P and Q is negation P or negation Q. Negation of P or Q is negation P and negation Q. And becomes or becomes and, De Morgan's law. It's as good as the set theory, complement of set theory, De Morgan's law. Okay, so let us do some examples on this theory. So let us do a few examples on negation of compound sentences first. Simple sentence is straightforward. We can take negation of simple statements, that is pretty straightforward. We can take negation of compound statements first. Okay. Talented. Yes. Curly hair. Yes. Third we can read as if it rains today. Then there will be no school tomorrow. Horses have wings. Snakes are poisonous. Sixth, for all x belonging to natural numbers, x is equal to 0. Okay, so first example says he is rich and talented. So let us convert this to symbolic form. We can say he is rich is P and he is talented is Q, and we say the symbolic form is P and Q for the statement. Now, negation of P and Q, if you are supposed to take, you can write this as negation P or negation Q. Now, negation P or negation Q, if you want to convert this to verbal form, we can say he is neither rich nor talented. So, he is neither rich, he is not talented. That becomes, he is, or we can say, either he is not rich or he is not talented. Okay, so negation of P and Q is negation P and becomes or negation Q, and negation P or negation Q is either he is not rich and becomes or he is not talented. Okay, so there has to be or here and becomes or. So either he is not rich or not talented. Okay, next is he has curly hair or brown eyes. So we can say curly hair brown eyes, and there is or in between. So we are going to take negation of P or Q in this case. So this is a disjunction. It will be taken as P or Q, and we're going to find negation of P or Q. Negation of P or Q will be negation P and negation Q. So negation P and negation Q. Here I'll use that neither nor. So he is neither he has curly hair, nor he has brown eyes. So neither he has curly hair nor he has brown eyes. He does not have curly hair and he also does not have brown eyes. So or becomes and they have to put not and not in both the sentences here, both the simple statements. The next statement is, if it rains today, then there will be no school tomorrow. So if it rains today, we can take it as P. There will be no school tomorrow. It will be taken as Q. No school tomorrow. Okay, will be taken as Q. And what I have here in the statement, this P implies Q. P implies Q, and we are going to take negation of this. So when I take negation of P implies Q, it is logically equivalent to P and negation Q. Negation of P implies Q is equivalent to P and negation Q. In P and negation Q, I am going to write it as it rains today and, or you can say instead of and, if you want to use the appropriate word, you can use still. It rains today, still there will be school tomorrow, and there will be school tomorrow. And also can be used if still doesn't strike to you. We can say it rains today, still there will be school tomorrow. Okay. So you should note here that in the original statement there was no, and Q was the statement no school tomorrow. So negation Q will be the statement, negation of negation, you have to take it as there will be school tomorrow. Q is the statement there will be no school tomorrow. Negation Q will be the statement that there will be school tomorrow. So it rains today, and there will be school tomorrow. Still there will be school tomorrow. Okay. Horses have wings if and only if they fly. Here I have double implication, right? So if I have used if and only if as my connector, the statement will be double implication, and I am going to take negation of double implication. Negation of double implication will be P and negation Q. As discussed here, it was P and negation Q, or it will be Q and negation P. Okay, P and negation Q or Q and negation P. So I'll not write the verbal form, it is going to be lengthy, but I'll do it orally for you. So when I say P and negation Q or Q and negation P, P is horses have wings is P, horses can fly is Q. So horses have wings and it will not fly, or horses can fly and they do not have wings. I'll repeat, horses have wings and they do not fly, or they have wings but I repeat, horses do not have wings and they do not fly, or they fly but they do not have wings. Okay, horses have wings and they don't fly, or they fly, horses fly but they do not have wings. Okay, so that is double implication of negation of double implication. Next statement statement number 5, but before doing that, I'll have to rub the first 4. Next is we have all snakes are poisonous. So we'll have to take the help of set theory here. When I say all snakes are poisonous, so there is a set of snakes which will come entirely as a subset of the set of animals which are poisonous. So all snakes are poisonous. All snakes are poisonous, right? We want to say if this is a true statement, right? If this is a true statement, let me assume the value of this statement as a truth value. Let us assume the truth value is t. Let us assume that the statement is a true statement, and I want to find the negation of this. So in negation, if this is true, I want to make it a false statement. So in negation, what I'll do is I'll take two sets such that one is not the subset of another, and we'll write like this. We'll show the intersection in this, and the verbal form for this will be some snakes are poisonous. Slash, you can also show it like this: all snakes are not poisonous. Okay, so we have some snakes as poisonous in this, and some snakes which are non-poisonous, right? So here we have snakes which are non-poisonous, which are not poisonous. Here there is no such snake which is not poisonous. All snakes are taken as poisonous. So if I take this as a true statement, then all snakes are not poisonous. Some snakes are poisonous and some are not poisonous will become this. This will be the negation of the statement all snakes are poisonous, right? So this is a false statement according to the statement which we have made earlier, that all snakes must be poisonous. This statement says that not all snakes are poisonous, right? Then there is one more statement which I can teach you side by side here is no snake is poisonous. Okay, no snake is poisonous. Now, no snake is poisonous means there is no intersection between the two sets. There is a set of snakes here, there is a set of poisonous animals here, and they have said no snake is poisonous. That means zero snakes are poisonous. Right? Again, if anybody asks you negation of this, you will come here and say some snakes are poisonous. When they say no snakes are poisonous, no snake is poisonous, we can write the negation as some snakes are poisonous. When they say all snakes are poisonous, we can write the negation as some snakes are poisonous. We can also write the negation as some snakes are not poisonous. We can also write the negation as not all snakes or all snakes are not poisonous. There are some snakes which are poisonous, but there are also some snakes which are not poisonous. That can be taken as a negation of both. Okay, it can be taken as a negation of the statement all snakes are poisonous. It can be taken as, this can be taken as a negation of no snake is poisonous. All snakes poisonous, not all snakes poisonous. No snake is poisonous, some snakes are poisonous, some snakes are not poisonous. Okay? Sixth example, we are going towards that. I hope this is clear. It is not confusing. All snakes are poisonous, some snakes are not poisonous. No snake is poisonous, some snakes are poisonous. statements. You can use any one of these three statements for the negation. Okay, so side by side we can clear this out. Some students are hardworking. You can say the negation of this, right? Some students are hardworking means there will be set of students, there will be set of hardworking people, and there will be intersection where some students are hardworking and some are not. It is this type of statement. So I want to write opposite of that, right? I want to make a false statement out of this now. So the statement will be, no student is hardworking. You can take this. So it negates the statement made there, because according to this statement, there are some students who are hardworking and some are not hardworking. But there are students who are hardworking. And the opposite of that which I have made here is no student. Not even a single student is hardworking. Right? Again, some students are hardworking. You can write a negation also as all students are hardworking. This also can be taken as negation of some students are hardworking. Some students are hardworking. The negation will be two ways. Zero students hardworking, or you can take it as all students hardworking, because here when I make the statement some students are hardworking, by default some are not hardworking. So some are not and some are hardworking, some are not hardworking. It is like this intersection. And you can take negation in both the direction. You can say all students are hardworking is a negation of this, because this negates the idea that some are not hardworking. Right? Or you can say no student is hardworking. I repeat, some students are hardworking. Negation is no student is hardworking. Some students are hardworking has another meaning also as that some are not hardworking. So the negation for that is all are hardworking. Some are not hardworking. All are hardworking. That's a negation of some are not hardworking. Okay? Okay, so we can say the negation of some are hardworking, no one is hardworking. Some are not hardworking, no, all are hardworking. Okay. The last statement, here I have used universal quantifier for all x belonging to a set of natural numbers. X square is greater than 0. If you want to write negation of this, universal means every natural number x square is greater than 0. It is a true statement. I am going to make a false statement now. So negation will be, there exists a natural number. So there is at least one natural number such that x square is not greater than 0. There exists a natural number such that x square is not greater than 0. And if you think, there is no such natural number where you square the natural number and it will not be greater than 0. Not greater than 0 means x square is less than or equal to 0. So no natural number, none of the natural numbers will satisfy this. There is not even a single natural number where the square is less than or equal to 0. All natural numbers will have square greater than 0. So this statement becomes a false statement because no natural number. They have said at least one natural number should have square less than 0 or equal to 0. Not possible. Okay, so when you're taking negation of universal quantifier, it becomes existential quantifier. If you take negation of existential quantifier, it becomes universal quantifier. So if anybody tell you there exists a natural number such that x plus 3 is 5. So do we have a natural number satisfying x plus 3 is 5? Yes, it is 2. So this becomes a true statement. I want to write the negation of this. So for all x belongs to natural number, x plus 3 is not equal to 5. Right? So is this a true statement? X plus 3 is not equal to 5 for all natural numbers? No. There is a natural number where we say 2 plus 3 is equal to 5. So 2 does not satisfy this. 2 plus 3 is 5 and 5 not equal to 5 does not satisfy this. So for all natural numbers, x plus 3 is not equal to 5 is a false statement because there is a natural number 2 which will satisfy this. So this is true statement. This becomes a false statement. Okay. So this is how it works, negation. So I will quickly write down the rules. You have to remember that negation of negation P is P, negation of P and Q is negation P or negation Q. Negation of P or Q is equivalent to negation P and negation Q. Negation of P implies Q is P and negation Q. Then we have negation of P double implies Q as P and negation Q or Q and negation P. Okay, so these are the rules of negation. Then we can say in negation you can convert all to some. You can also convert no student hardworking to some students are hardworking and vice versa. Okay. All students are hardworking. Negation will be some students are hardworking and some are not hardworking. Reverse. No student is hardworking. The negation is some are hardworking. Or you can again say some are not hardworking. It means the same. Some are hardworking, some are not hardworking means you are talking about intersection. Okay. For all can be taken as existential quantifier, and in return existential quantifier should be replaced by for all in negation. Okay.